Start sending us your video for your streaming software to go live. Oh, okay. Now it decided to kick in. Okay, YouTube. So we're online on YouTube as well. Success. Okay, give me 10 minutes. I'm gonna make some tea and then start the stream. The topic for today is basically continue what I was doing yesterday. I made some progress offline. So now we are gonna basically continue down that path of making networking code just a little bit better. I'll be right back. Okay, I'm back. Okay, so let's get started. Do-do-do-do-do-do. Hello, Dax. Hello, hello. Okay, so yesterday I implemented correctly basically the ability to pre-compute how big a message is going to be. I'm using a bunch of metaprogramming to make that happen. So I know how my structs behave. And so some trivial ones that don't have any specific shenanigans going on with them are going to have numbers, enums, uh, slices, strings, basically, and maybe an embedded struct, which in turn is going to be equally simple. So computing the total size of these things, easy peasy. But then there are some structs that are complicated, where basically they contain runtime data that you don't want to serialize. So those guys specify a function called TCP size field that basically allows the struct to tell us what's going to be their size as a field inside of a TCP message. Here's some print logging that I don't need anymore. Although these I don't need. These I'm gonna leave here in case it becomes useful in the future. So yeah, so this was not too complicated. So now I'm happy. Now let's make things even better. So I've implemented this thing called debug assert full, which in debug mode asserts that a message at a given point in time, which in our case here is when we are done creating the message, that's where we put the call, basically checks that the message doesn't have any unused bytes. We could, in theory, like, there's nothing bad. There's nothing inherently bad in saying, well, I'm going to allocate 100 bytes and then use 90 of those. That's fine. But in reality, since we can be extremely precise with how big our thing is supposed to be, we don't care about this level of imprecision, and so we can base. And also, when that imprecision happens, is because our function that tells us how big a message is supposed to be is out of sync with the actual serialization code. So it's basically a bug in that case. So I had this check. Now, here's what I want to do. I'm thinking that this should not be a separate function anymore. And I'm thinking that this check shouldn't be debug only. I think this check should maybe even always be on, considering that it's like a number comparison. So like there's really nothing to lose by keeping it around always. And instead of having somebody call it at a critical moment, meaning that they could also forget to do it, we know when is the final moment where a message has to be right. And that's when somebody tries to extract the payload from it. So tries to get this. Our TCP message has some like a header, and this is what we send over the wire. So this stuff is useful for us for bookkeeping server-wide. This is what we send over the network. So the idea is, well, since you have to call payload to get that pointer, well, you don't have to, but you probably will. So let's put checks in there. And guess what? It's also convenient because we already have access to header here, since we need it anyway. And so this way, basically, we can delete this function. Okay, so no more need for that. Now, here's another improvement that we can make now. I have a message. We pre-allocated a size for it. And then we extract a writer from it. So I basically implemented the writer interface. The problem is that, so what we gain from this is that we basically get for free implementations for write byte. That one is not particularly useful though. We get write int. That's one is a little bit better. And we get like write slice. The problem is that the writer interface assumes that like normally your write could also fail. Well, in our case, actually, yeah, this is not really the case. We don't fail here, or rather, a failure, like the fact that we don't have enough space to write, it's actually a crash. It's a programming error because we always can pre-allocate the correct length. So, what I want to do now is go away from the writer interface. So that we can avoid having to use all these tries. Like this is a bunch of error handling, which is actually it's not real. Like these things are never gonna cause an error. We only think there's an error because the writer interface assumes there might be an error. So, alternatively, I guess I could create it not on any writer, but a writer. Is there like a generic writer inside IO? Generic writer deprecated. Consider switching to any writer or use generic writer. Okay, so it's function generic writer, I guess. Okay, so I guess alternatively, I could create a generic writer, keep using the writer interface, but state that my function doesn't produce any error. That could also work. The problem is those writers would have to be cannot be passed around as any writer anymore. You know what? Let's do this for now. Let's switch from an any writer to a instance of a generic writer. Context, TCP message. Yeah, we even get control over our context at that point, which is pretty nice. Write error, empty set, write function, write function. I guess we can give this dude a name. Okay, what do you put in a generic writer? Context. Oh, right, it's comp time. So you don't even put the function there. The function is bound statically. Oh, yeah. Okay, so in theory, by doing this now, in here, every try should be a mistake. Let's see if that is true. That is not true. Oh, man. So we need to change something. So empty error set should do it. But I think we can do even better, right? So the writer is not allowed at all. So I guess what's happening is that since the error set is empty, the try, there is an error set. So the try is allowed, but I think that if I omit the try, then it will still compile, it will not be a compile error. But I want the try to be an error, man. Oh no, there we go. No, it is an error still. Error union is ignored. Yeah, but I don't want that, man. I don't want that. You know what? I guess we're not going generic writer after all. We're implementing our own stuff. No writer. No writer at all. So we have a private write function, and now we create publicly our specific implementations. So pub function, for example, write byte. That's one. The one is going to be easy. Also, this one doesn't even need to return a usize. There's no point. Void. So write byte. This should work. Now we need write int. Oh, here's also what we gain. Then now we can make our own write int, and we can implicitly force little endianness everywhere, and nobody can stop us. Okay, so we are given an int. Maybe we should assert that if type info of t is different than dot int, compile error, not an int type. Okay, so once we have that, I guess we can just do as bytes. And I think they're basically all going to be like this. So we have write byte, write int. We could do write enum. Also, write int, maybe we can even make this an any type at this point. Yeah, this also makes it even better. Write enum, write enum, write enum. Let's do write enum. It's going to be pretty much the same. But where does that int come from? The expression, the built-in type info, gives you a value of type std.builtin dot type. So you go to definition, it's in the standard library. You can also find, it in the docs. And that's a union. It's the union of all possible Zig types that you can do a reflection upon. And each one of these contains stuff. Like, for example, let's say that you found a struct. You look into the struct and it tells you what type of struct it is, if it's like packed or not, or extern. It tells you the list of fields, the list of decals that it contains, and if it's the tuple or not, etc., etc. So yes, this is a compiler built in, and it does some magic, but it results in a value that you have defined in the standard library. So that's where I know what this int is. So we have write byte, write int, write enum. We need write slice. Oh, now we need write slice and then like whether it's a small, medium, big slice. So here's my conclusion with regards to this stuff. I'm thinking that I want small slices to be U16s. So small slices can be up to 64 kilobytes big. But this application will definitely need sometimes to have items, things that are bigger than 64 kilobytes. Not often, but there will be some. Profile pictures. Somebody shares a file. Why take any type? Why not take enum? There is no generic, there is no keyword in the language that I could use to say that I could put here to say, give me any enum, anything that is an enum. There is no more precise way right now in the language. Are any writer and generic writer analogous to interfaces and traits in other languages? Yes, they are. There's a connection there for sure. More specifically, I would say they both are interfaces. Honestly, the nuance around traits is a little bit. I'm not sure I know it fully. But in this case, these writers are interfaces. So I'm guessing you have seen writers in other languages. So the idea is, you have a file and then you grab, somehow you turn that file into a writer that writes into a file. But then you could also have something that does the same, but it writes to memory, like into a growing memory buffer, or writes to a socket, right? So you can have basically writers that write to different things. Sometimes people also get fancy and they even give a writer interface to stuff, to more complicated stuff with weird semantics. Like, for example, you could have a CSV writer. I've seen, I think in the past, a CSV writer. And what the CSV writer would do was basically, I think the stack was like this. There was a file. And then on top of that, there was a file writer. I'll go with FW. And then on top of that, there was a CSV writer. And the CSV writer would, and so when you wanted to, for example, you wrote, I don't know, a string, I think the CSV writer would, I don't remember how that thing worked. I think that every time you issued a write, it assumed that a write was a cell in a CSV file. And so it basically automatically inserted separators between cells. So you call write twice. That means that you're writing two cells. And then if you write a new line, then that becomes a new row. Well, the new line gets placed verbatim. But then in other cases, like if there were like quotes, for example, it would escape them using whatever escaping mechanism CSV wants. I don't remember. So you can get fancy. It gets weird though. Like once you start doing stuff like a CSV writer, it gets really weird. Like you're starting to trade convenience for weirdness, and users don't know anymore what's going on with your library and are exponentially more likely to misuse it. In any case, the point is, yeah, you have a writer, so you could be writing to different things. And as long as something accepts a writer, then if you're writing to a socket, to a file, to memory, it doesn't matter. The difference in Zig between any writer and generic writer is about the error set. So an any writer is a quote-unquote type erased writer. So you can accept, any writer is a struct that exists in the standard library, right? std.io.any writer. And you can go to definition, and it's this guy. It's a bit of a weird struct because you don't see any writer written in here explicitly anywhere, because this is a top level struct. These are the two fields of the top level struct. It's another Zig funky thing. But in any case, this is a concrete type. But generic writer is not concrete. Generic, well, as the name implies, generic writer is generic. And in the case of Zig, we do generics via functions. So instead of creating a type with diamond brackets, in Zig, a generic type, like let's say you have a generic list that you can use to make a list of different things, that's going to be in Zig a function called Pascal case list, so uppercase L list. And then you pass to it the type that you want to put in your list, and then you obtain a specialized list type. And that's what this generic writer is doing. So you pass it some type stuff. It doesn't always have to be type stuff. You can even pass numbers, values, but whatever it is that you pass to these guys needs to be known at compile time. And so then they create a specialized type. They literally return a struct, not a struct instance. They return a struct definition, where basically some of the things that this struct does is parameterized against the values that you pass in. So and any writer can return any error. Like if you look at the definition of write function, let's look at the other one. Oh, really? Editor doesn't... my editor... Okay, wait. My editor forgot. So if you look at the definition of any writer, first of all, these are function pointers, which implies that this can be changed at runtime. And the second is that it returns any error or usize. So the write function could return any possible error value. In Zig, errors are just enums. They don't contain a payload. So that's why they can be type erased and this way. Obviously, if an error had a payload, then you couldn't easily homogenize them. In any case, long story short, if you're using an any writer, you don't have static knowledge of what are the possible errors that a writer returns. Instead, you look at generic writer. You can see that the write function has to be known at compile time. So that means that you cannot, it's not even saved in the struct. It's like it's hard-coded statically in this type. Not even something that you can change at runtime for any specific instance of generic writer. But then also the error set is parameterized. So it allows you to basically to say, yeah, I can have either a generic writer that writes to a file, and that way every possible error that comes from dealing with files, like even like, you don't have permission to write to this file, that will be tracked and will be known also from users of the writer interface. So if somebody has a writer tries to write to a file, then in their error set that they will have to deal with, they will know that, no write permission, whatever has to be handled. The downside is that then there is no one concrete instance of this guy. And in Zig, we don't have right now a precise way of talking about interfaces when accepting values. So we basically have you can either accept a concrete type. So like TCP message here, this is a struct, and I can say that I accept that. Or if you accept, multiple types, because that's what a generic writer is, then you have to use any type. In my case here, I'm using any type because I'm accepting ints, but I want to accept different types of ints, U8, U16, IE7, whatever. So I don't have a way of saying, yeah, an int, any int. I can only say any type. And then if I want, I can put comp time checks that complain if what you pass in, if I don't like what you pass in. I don't know if this is going to stay like this forever. I think there are good chances that this is going to change slightly. But it's kind of the trade-off, a trade-off that Zig got itself into. This might seem kind of annoying, like just a straight downside, as I explained it up until now. But there is a very curious upside. In Zig, generally speaking, when you do like metaprogramming, like generics, that kind of stuff, you don't do it. It's like, in a sense, it's structural. It's structural interfaces or duck typing, compile time duck typing, where the idea is let's say that I had a way of saying that something has to be a list, right? So I can say that they can be a list of type T. This is not correct Zig syntax, but let's imagine that this works. So if you were to do this, then that means that the only thing that I accept are things that are instances of lists, of this list function that maybe exists in std mem.list. Again, making this stuff up. But in Zig, you don't do this. And the advantage is that what you do then is you just use it as a list. And then it doesn't matter how the user, like if the user made their own instance of list that is able to fulfill the same trait, because at this point it's not an interface in terms of runtime polymorphism. So maybe that's why people use sometimes the word trait. Although, to be clear, I'm not using it in any specific sense. Like, I don't know, I'm not using it necessarily in a way that makes full sense for example, Rust users. In any case, by leaving this underspecified, you allow people to do structural traits instead of identity traits, right? So if this was list, then you could only pass in instances of list. But if this is any type, then anything that, like, if I end up using, I don't know, dot append, then as long as they give me something that has dot append, it will work out. As to how desirable or not that is, obviously up to debate. There's pros and cons there too. But in general, the duck typing approach at compile time in Zig has been great, because duck typing at runtime causes runtime errors, right? Duck typing at comp time causes compile errors. So as long as you don't go too crazy with this stuff, making it so that a user is so confused that they have no fucking clue as what it is that they're even supposed to give you to make your function happy, then you gain a good deal of flexibility that can have practical upsides. Let's see, any type followed by comp time error is Zig's way of putting bounds on generics. This is sort of the same thing as dynamic sum trait in Rust. I think the dynamic sum trait, though, is runtime polymorphism. Is it not? Isn't dynamic for runtime polymorphism? Well, in any case, what I would say is this is definitely an important part of the language. But when I started programming in Zig, having a lot of high-level programming experience in my brain, poisoning my thinking, I thought that I had to, I have to design this thing. First thing I'm going to do, make an interface. Turns out that actually, you don't really need that stuff. Not to say that interfaces are bad. Interfaces are not bad. Interfaces are a great concept. But in reality, for example, runtime polymorphism, more often than not, you don't need it. You really don't need it. It has a performance price. Like, it has mechanical implications in terms of what the computer can and cannot do once you need runtime polymorphism. And if you don't need it, like, everybody's actually better off without it. And you can go very far without it, like without any compromise. So, like, for example, if this were a high-level application, I guess I could make a TCP message interface, and then anything can be used as a TCP message interface as long as it has a, payload method. And then everything else could be up to you. Sure, but like in my application, is this useful? Not at all. Not at all. And in some higher level programming languages, you tend to do a lot of this for no good reason. Java, C#, even Go is a little bit like this. So I guess my point is, know that as uncomfortable as this might be, especially if you're used to using interfaces a lot, man, go on a detox. Go on a detox from interfaces, and you will find out that, yeah, this is a minor annoyance that occasionally will happen. You write a one-liner check just to add a little bit of sanity and hint at the user that what they're doing wrong, and then everything else will work out very easily. Let me finish this implementation and I'll show you. Like I'll trip my own errors so that you can see what the user experience is when you use these things wrong. By the way, this is great. Like this is your superpower. The fact that you put in your compile errors is like it allows you to be precise in explaining what it is that you don't like, and you can even check for properties that you cannot normally express with traits and interfaces and generics. Because here, I could check for way more stuff at compile time than what you normally can. So let's see, right slice. You give me a slice. Well, you know what? I guess that's right function, basically, now that I think about it. So maybe we upgrade this guy gets upgraded to right slice. Yeah. Okay, let's see. So we have this. Now, protocol server is now completely wrong. No fin function main writer. Yeah, no more writer, dude. Now we do MSG. Don't even try, because we can't fail, because we pre-allocate all the size right away. Oh, right slice. Oh, now I remember what the problem is. So no, this guy cannot be right slice, because right slice, like the public interface, also needs to prepend the length of the slice. I was saying something really stupid a moment ago. So right slice, first writes the length of this slice. Then I guess we could call it right. Okay, we could either have right slice and right small slice, or we could have right slice and then have a parameter that says how big the slice should be. Pub const slice size equals enum, and I guess be small, big. We could even do, I think, this. We could say U16, U24. Let's see. Okay, so we switch size. And depending on the size. So, by the way, these guys have the same name as integer sizes, because that's going to be the integer size that I'm going to use to write down the size of this slice. But I'm going to say these are enums in this case. That's why I'm putting a dot here, because these are enums that happen to have the same name as the sizes they want to represent. To be honest, I could like even accept just a type directly, but then I wouldn't be able to restrict users into only choosing one of these twos as easily. So I'll just make them an enum. Hello, is the inline keyword the same as the inline in C? Do we need something like static inline in Zig to make inline functions? So is inline in Zig the same as in C? No. In C, inline, when given to a function, so I'm assuming that you're talking about inline given to a function. In Zig, you can use inline with a few other things, like you can do inline for example, or inline else in a switch. Those are different things. But, or rather, in Zig, they tend to always, it's like the same basic concept. But in practice, I'm assuming that you're just talking about functions. So inline in C is a suggestion to the compiler to inline the function. In Zig, it is not a suggestion, it is a command. So in Zig, if you try to inline a function, like if you define a function as an inline function, and then the compiler is unable to inline it, that will become a compiler error. So that's one big difference. Second difference, which is more subtle, is that in an inline function, in the process of inlining, the function kinda inherits comp time knownness of its arguments. So if you make a function inline and then one of the arguments happens to be comp time known in the caller context, then the function body will also be simplified according to that rule. That said, in putting inline in front of a function is a bad idea unless you really know what you're doing, because the compiler can always do inlining if it decides it's a good idea. While if you put the inline keyword, the compiler, even if the compiler thinks that it's a bad idea to do the inlining, the compiler has to do the inlining because you are demanding it. So don't put inline in front of functions unless you have a real reason to do so. As for static, as far as I know, static in C just means that the function is like the symbol is not exported from the current compile unit, so compilation unit. So I think so. I'm not sure what that would even mean in Zig. So I would say no, we don't need static inline. Okay, so it's a U16, so we do t.write int. Oh, and I can show you in line else now. So we do write int of len. So this passage here basically is by default, the len field of this slice is going to be a U size. It's going to be on a 64-bit machine. It's going to be 8 bytes. But we want to restrict this to 2 bytes. So we have to do an int cast. And this int cast is also going to contain for us a safety check that will basically crash the program if we try to take a slice that is too big, that it is longer than 64 kilobytes, because then that number cannot be represented inside a U16. So this mapping process, it's not just a mapping, it's like also a conversion. And then we do write int, we pass it len, we grab the type of len, which is U16, and so it works out. Now, if I want to do U24, guess what? We would have to do the same, right? But here, U24. So we can do this. This works. This works. Or we can do something better. We can do, I think, inline. Although, if we do inline, then how do I specify what this guy should be? So inline would allow me to collapse these two cases. The problem is that I need to put this guy down, and I don't have a easy way to go from an enum name to a type, to an integer type of the same name. So you know what? Never mind. No inline. We go explicit. Better this way. Okay, so if it's a U16, we write a U16. A U24, we write a U24. Hey, bro, I'm starting to be a programmer in Russia and starting with Sharp in Visual Studio. VPF.net. C Sharp. Okay. Is it good? Oh, so the question, is it good? Kinda implies things like, is it good for finding a job? Is it good for learning software engineering in a absolutely good way? From a job security perspective, I guess you know best, like look at job offerings around you, see how much C# is going versus Java, for example, and see what you think. If you're in Russia, chances are that given how things are going in terms of politics, you might want to not invest too much into a Microsoft technology because it might be yanked away from you one way or another. So maybe Java could be a better option. But then again, if businesses around you, like if in Russia everybody's doing C#, then you of course want to do C#. Just saying though that you need to be careful because given sanctions and everything else going on, for example, I suspect that right now Microsoft is not even legally allowed to do any business in Russia. You can still have C#, like nobody can take away C# from you because that's open source. But still, there might be some weird consequences there. Then when it comes to whether C# is the best way to learn the ultimate truth about software engineering, I would say that the language itself is not necessarily the problem. I think that C# as a language is a really good language. I think that as a ecosystem is a very bad ecosystem. But what is, I think, more important is it's not the language itself, but the culture around the language. And the reality is that with C#, with Java, you tend to, people who tend to, and companies who tend to use these languages really like a lot enterprise style software engineering. Enterprise means there is a big company with a big customer. The software is actually in reality not that hard, but it is complicated to make because, like, imagine that you need to make a some kind of internal system for a bank, and the bank is gigantic and it has very complicated needs, some of which don't even come from the bank, but some requirements are there because the bank has to follow certain regulation. Then there are like the bank is subdivided into, I don't know, 20, 50, 100 different sub business units, and each business unit has its own internal rules. So when you create part of your software that has to be used by that business unit, they want to have things work the way they like, which might be very incompatible with how other business units run their stuff. So you get to a point where basically the software itself really is going to be something stupid at its core, like stupidly easy at its core, but you have a lot of very weird human problems all around it, and that's why software enterprise grade software engineering exists. It's a thing. People specialize in that. They make a career out of it, and then they never learn how to program well, because the reality is that ecosystem is horrible for learning how to program well. It creates value for society, like it's good that it exists, but it's not a great way of learning interesting stuff when it comes to software engineering. So for example, if you could still do C#, but then you might take a look at what you can do with like Unity or Godot. I believe that both allow you to use C#, so you could look at how to make games. Making games is also an interesting subculture of software engineering, where people that make games are definitely, well, AAA game development, like people making Call of Duty. Those people, it's exactly like making software for a bank. They are just as bad, I suspect. But then you have, like, if we're talking about Unity and Godot, those are like indie developers, and they have a wildly different perspective on software. So I guess my point is, all things considered, the language doesn't even matter all that much. You definitely do not want to get stuck with one language. But once you know one language, learning a second language will be dramatically easier. And if you become a professional software developer, you should learn more than one language. Like, I don't think there is any one good software developer out there that only knows one language. Obviously, there will be one language that becomes your main language, the one that you know best, that you're most comfortable and productive with. So that's fine. But once you learn one language, the second one is going to be dramatically easier, and even a third, fourth language you can learn very easily. And then you can choose, like you try a couple more, and then you decide if you want to keep using the one that you use or move to something else. So long story short, it's fine. Start with C#. Don't stay only in C# forever. Look into other things eventually and see if you like those things more. But ultimately, really, it's not just the language. It's the specific subculture that you're getting yourself into. People who do enterprise software development only know a fraction of what it is that makes good software engineering. But at the same time, other subcultures are roughly in the same boat, just in different ways. Like indie game developers might know a lot of things that enterprise software developers absolutely don't know, that should know. But the same is also true vice versa. People who have never seen any enterprise software development process, they only see the bad outcome. They think, oh my God, how can these people be so dumb to always make the bank software bad? And the reality is that, I promise you, take those people who made that comment, plant them into the ecosystem that creates software for banks, and they would have the same, if not a worse outcome at the end. Because life is freaking complicated. So try different stuff. Sorry, that was a very long way of just saying try different stuff. Starting with C# is fine. Okay, so U16, U24. So first we write the length, and then we write the slice. Okay, so we have our right slice. So utils right small slice. This guy should be dead now. Oh, this entire file is dead. Oh, let's go. This entire file is dead. Let's go kill it. Goodbye, utils. Okay, so write byte, write int. Now write int doesn't even accept lethal anymore. This becomes message to write slice. Actually, there we go. And I guess we'll have to do the same with everything else. Oh. So I'm making a fake W definition so that I can then do LSP rename on it, rename it to MSG, and then nuke the definition. And now every W has turned into an MSG. Remove.lethal, remove lethal. Man. Oh, you know what? We even remove this. Oh, fuck. But then we can do count. So we need to do this as. So let me maybe explain what's going on here. my definition of write int doesn't expect you to define the type of that integer anymore. That's actually a little bit error prone. I'm starting to think that that's a bad idea. But if you only use it for with the right things, that's so like if you get this wrong explicitly, you know what? No, okay. Just maybe write it as a comment. Okay, so here's what's going on. Whenever I want to write an int, for example, hey, Il Fautore, thank you very much for the Prime subscription. Thank you, thank you, thank you. So whenever you want to write an integer, in this case, let's say that it's the channel ID, we immediately look at the type of this integer and we know how many bytes to write down, U64 in this case. But here, this count, I guess if I want to make this count a chat ID sized counter, I need to use as. Although alternatively, we could just make this be naturally what it needs to be, not impose a size on it and call it a day. Now the problem is that then that would give trouble with that would have trouble with clients that have a different U size. Let's also add another check. If type of value U size, if it's a U size, then we should complain. Because a client that has a different, like a 32-bit client, would disagree on the size of a U size, and then it would not read things correctly. So that's actually fine as is. Okay. So what I was saying is, yeah, basically normally the value, the type of the value drives the how many bytes we write on the wire. But then if we use this thing, for example, this is count from a array hash map, then those things are naturally U size. And I was saying that if you don't have the as, then that's a bug. Like you silently leave a bug. But by banning U size here now at comp time, then this is not a problem anymore. Let me see if I can. Unfortunately, we don't see the errors yet because everything else is still broken. So let me fix everything. Once I fix everything, I will recreate some errors for everybody so that you can take a look. Also, we're having like a build error somewhere. Oh, in message. No utils. Yes, goodbye utils. D2 message. Oh, this guy has a serialize. Oh yeah, you don't give me a W any type anymore. Oh fuck. I'm sorry, I don't have a benzene, but you can go to these websites to learn more about it. Right. Unfortunately, now we lost read slice, which we need to implement somewhere. So maybe nuking all of utils. We nuked a little bit too much. I still need the ability to read. I guess we could put it in TCP message and use that as the where this location is, like where this stuff is located. But we're not gonna have a TCP message instance when reading. We're just gonna have a buffer. But maybe we could put it there no matter what, like as a static method, quote unquote. Using an unclear identifier TCP message. What do you mean? Oh, right. It's protodot. Okay, so this is kind of fixed, I think. I think also read int at this point. You know what? I think also it makes sense, right? For like the inverse operations to be implemented in the same type. So okay, let's do this. Let's do it like this. Okay, need to implement these guys now. So here I'm using any type because of a generic reader thing. So I don't care about the shape. I just care for it to have read byte itself. So to be fair, maybe read byte is the one that it's not worth implementing on our own, and like the one that it's in the reader interface is already perfectly good. So let's not implement that one. But the other ones, it's worth it. Fab function read int. You give me a reader, and I return you a. Oh, you also need me. You need to give me a type for that int. And I give you your T type. And guess what? Same rules apply here. Your T has to be an int and has to be different than usize. Then we do return. Also, this will have to return an error, I think, at least for now. Return try, well, whatever. Reader dot read int, and we're gonna read type T, and we're gonna read it dot little. Okay, then we want read enum, I guess, which is kind of like read int, except it's an enum. Now I need to grab the size from this enum, the backing integer. Tag type. Right? Tag type. Yeah. So we need to write down this type info. Okay, this should be super clear. Then we need read slice. That was the biggest thing. Pub function read slice. I guess you need to give me a size. And then you need to give me, well, you need to give me an allocator. So GPA. You need to give me a size, and then you need to give me a reader. Okay, the way it works is first we read the length. Oh, you know how we do this? Man, check this out. Check this out. Oh, man. Yeah, that's how you do it. So, okay, I can actually show you the inline else with this in place, because then I can do this now. Instead of having two copies of these, I can do inline else. The type of this variable is going to be s.int type. And that's it. That's it. That's literally it. That's literally it. Okay, so read slice, and we kind of want to do the same. So we want to do const len equals switch on switch over size, and guess what? We do kind of the same. We want to read instead of write. In this case, we want to read. So we do read int. Don't even need to specify it here. Okay, so I'm doing this wrong. Int type, and then the reader. There you go. I think we can even do it like this. There you go. Len is going to be this. And then we just need to read a slice. Well, we need to allocate, I guess. try this. We also need to try this, I guess. So we get a slice, and then we try to read into it. R dot read slice. No, read all. You know what? Let's quickly take a peek at what the original implementation of this stuff looked like. Hello, Pluto imp. Source D2 protocol utils. So alloc and then read no EOF. That's what we did. Okay. There we go. Now we have read slice implemented. Okay, so now we can start using this stuff. Let's see. So let's make this guy better, I guess. Oh, we have an error. Where's the error? Yeah, no more utils. Sorry, utils is gone. Utils is goner. Oh, and now it complains about reading stuff. Okay, you know what? Let's not follow the errors. Let's go linearly top to bottom. Easier this way. So write byte. Here the tries don't exist anymore. Then let's rename W to MSG. Heal W because everything is the message itself. Write byte easy. Write int. No more need to specify the integer. No more need to specify the NNS. Write byte. Write byte. Write slice. Write slice. Then once. Now it's message dot U16. That's a U16 slice, I guess. By the way, this code is, every time I'm polishing it, like it becomes so much better than when it was before. So now let's take a look at the reader. Let's take a look at the reader. So now this can be TCP message dot read int. We do have to specify the size. We definitely do not have to specify the NNS anymore. We still need to try though. Read byte can be the same. No need to change that. This becomes TCP message read slice. We need to specify the size. Dot U16. And basically these has to mirror these. Okay, so one struct down. A few to go. Okay, this one we were already changing. So let's continue the work. Write byte, great. Write int, great. Bunch of tries. Bunch of tries. No more tries. Write int doesn't require this anymore. Write int, write slice now requires let's say that it's U16. I think we're making them all U16s right now. Eventually, maybe this is gonna have to change, but for now, it's fine. Write int doesn't require this anymore. Doesn't require this anymore. Doesn't require this anymore. Doesn't require this anymore. Not even this. Write slice. Just wants U16. Okay. Delete all tries. This needs to be as. Oh yeah, this needs to be a as with also a int cast. I think these guys also need int casts, maybe. You know what? If they do, we're definitely gonna get complaint from Zig. If they don't, then Zig is gonna be happy. Okay, right, int doesn't require this. Okay, so this struct is well, the serialization is okay. Now we need to do the deserialization part. Fine. TCP message read int. Okay. Man, this is so boring. I could probably make macros and get more stuff done right away, but I will probably also mess them up and then spend more time trying to fix the mess that I made, I suspect. But let's try actually, out of curiosity. So what if I were to select in this area read int? So how do we want to change this? We want to change this to being TCP message dot read int. Then in read int, we want to, I guess we want to do till and then closing parentheses. Oh no. Till closing round parentheses. Till dot, or find dot. Okay. Matching our argument, comma. Okay, so technically it did work. Almost. We need to pass R as the second argument. Okay. Yeah, that's actually not that bad this way. Okay, a few more, but these ones are small and easy. Hmm. Can I do go to argument? G argument? Access file is A, so no. I guess I can do B, a bunch of B's. Machine argument, delete. Oh, look at this. Write byte int from enum. We can do write enum now. Oh, I can't use easily read enum here. You know what? I'll leave this for like this for now, but I will fix the rest. Write byte, write int. Okay, parse. Hmm. Okay, last two. Last two structs and we're gone. We're done. Oof. mcd.msg. Oh, okay. Oh, it has its own serialize function, which we already adapted. Nice. Write int u32 int cast channels len. Yeah. Okay. Then read byte. Okay, in theory, this is all done. There's probably some compilers somewhere that we need to fix. Some other secondary types that we haven't upgraded yet. So let's get there. And also just mistakes done in general. Okay, so media has utils in here? Really? Oh, proto media. Yeah, no utils here, sorry. Oh, everything was even commented out, so okay. That's fine. 1 error gone. Client.zig? Oh yeah, protocol client.zig. Oh, okay. We'll need also to fix that one eventually. Well, soon. Message 31. Read slice, right. Yep. Whoops. Sorry. Yep. Sorry. I killed everything. Well, the good news is that this guy is not too complicated, it seems. So, yeah, only authenticate, call join, chat message send, channel create. Yeah, there are not a ton of client requests that have been implemented yet. So, I guess we just need to fix those. The problem is this like a TCP message still, even in our case? I guess so. I mean, we don't care about the ref counting. So, the ref counting bytes are wasted, but I mean, that's good enough. And actually, here's the funny thing. We could even specialize. We could change how TCP message works for client. We have a compile time flag that tells us if a given piece of code is being compiled for the server or for the client. And we could like literally straight up say that on the client, the header doesn't contain the ref count field. Easy peasy. Like really easy peasy. Okay. So shall we update these guys? I think it's time. Let's update these guys so that we stop getting these errors and then we go forward from here. Okay, authenticate. This is gonna require some work though, so please bear with us. STD. STD? No. We need Proto. We don't even have Proto in here. So we want to create a TCP message, and we need to pre-compute the size for it. Well, in this case, it's very easy. Authenticate is so simple as a request. You know what? Let's also get that bad boy here with us. So get TCP no TCP size. Okay, we don't need a writer. We don't need to write a preamble anymore. This is a try. Right slice out username. U16. We don't do any of these things. Yeah, this is like stupidly simple as is. There we go. Okay, and now it's gonna be a matter of doing the same everywhere else, pretty much. No preamble. MSG write int. Ba-da-ba-ba-ba-da-bum. Oh, also I forgot to give it protocol. Okay, in this case, protocol can be empty. Ba-ba-da-ba-da-bum. Chat message send. What do we do with text? We kept it big. We also kept it big on the other side. But are we doing it right? Oh no, I introduced a bug. Yeah, this system is not great. I put these things are now out of sync. That's unfortunate. That's fucking unfortunate. We this should be all kept in sync. Like I should even use what I should do protocol.sizes.text basically here. It's okay though. We'll make these things better. We'll make these things better eventually. Okay, so message send. That's a U24. Let's go. Then serialize, create a message, then write preamble. No, we don't do that anymore. Oh, you know though what we do? We do write the marker. Also, we don't have try anymore in front of. Okay. We don't do this anymore. Okay, last struct. Well, then we're gonna have to fix also. Maybe it's usage. I'm actually not sure. Oh yeah. Also, yeah, we need to fix usage slightly. Slightly. origin ID, blah, 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 blah. I think that's right int channels kind size. Oh, I put the size inside of the enum like this so they could be accessed easily. And that was smart of me, I guess. This is just a write enum, basically. This is just an overcomplicated write enum. Channels.kind. Perfect. So we don't do this anymore. Uh, pa, pa, pa. Read slice. Oh, I didn't put the length U16 though. Okay, then we need to do something more because this is a read int. This needs to become a read enum. There we go. Okay, so oh, this doesn't even need this anymore. Thank you. Nice. Yeah, so that was it. Now we might have introduced bugs, and also we have to fix usage code. So we need to fix a few things. TCP message. Now client definitely has wrong usage code. Invalid format string S for protocol TCP message in FMT. Oh god. Okay. Going to network. Any errors for me? There we go. Give me errors. So we want to do call join, and then we do hct.send, but send wants bytes. Let's change this to MSG. We make it a TCP message. We don't even have TCP message in here. Do we even have protocol? We don't. It would be d2.protocol. Okay. So this is so Kirk. Today the agenda for today is refactoring of my networking code for a Discord alternative that I'm writing, but it's gonna be very boring because you're not gonna see any of the application. You're just gonna stare at compile errors. Probably for a while more. Not a lot more, but a while more. Okay, so this sends the payload, then result. Yeah, we just did not give a fuck here about anything. So now we are gonna be good boys and we're gonna free that stuff. Okay. So we fixed some usage, but not all of it, clearly. There's a print that we're trying to do, and this thing doesn't like it anymore. Okay. Expected union type found void. Oh, right. Okay, now we have the printing errors. These are very annoying. Protocol client trying to create has no protocol namespace. Right. So this is an error that I made myself, where I want my structs to have a protocol namespace if they participate in the serialization stuff, so that I don't accidentally pull in structs that I don't want to pull in. So let's go do that. And this guy totally needs one also, because he needs to specify the size of its slice. Name should be a U16. Is that right? Yeah, it's a U16. Okay, now we need to fix the printing errors. Oh, man. Client media, client network, client media, client network. Oh, there we go. What protocol are you working on, if I may ask? I'm writing a Discord alternative. So the protocol is what the client is going to need to talk to the client, to speak when connecting to our server, to be able to, authenticate, get messages, chat, that kind of stuff. So MSG is problematic in terms of printing it like this right now. So here's what we can do. Maybe we can give to MSG the ability to format itself. How about that? How about that? What if we were to do the unthinkable? So pub function format. I don't remember the signature for format. So it's definitely a function that returns an error. There's going to be self, which is going to be a TCP message. And then there's going to be FMT, which is going to be a slice, which I think is going to be comp time. Then there's going to be the output stream. And I don't remember what else it needs. Options. It needs options. Or does it? I mean, FNT contains options. What other options could there be? Yeah, I think they should be fine. So basically what I want to do is try out.write print maybe. What do we want to print? Like the length? I guess for now it's good enough, because this guy doesn't know about the structure of what it's inside of it. So maybe in the future we could make it print like a hash of the message, so that you could recognize messages by having identical hashes. Maybe. In any case, length is going to be self.header and okay, let's see if we got the signature right. We definitely did not. Member function expected 2 arguments, found 3. fuck? Actual FMT options writer. So there is options. The fuck is options though? Is this it? Format options. There we go. Okay. We're building. I'm running, oh, well, the client. Let's now fix the server then. Protocol server 222. There's a bad try. There's a bunch of bad tries. $260. No, man. Error is ignored. Oh, fuck. There's one that I didn't delete too many. Although that's serialized. I bet you that the serialize in turn shouldn't return an error. Yeah. Oh, there we go. Error, not an enum type. So we tripped our own compile error. So it means that somewhere we are passing something that isn't an enum. Protocol 174. What's causing this though? So this error comes from server 442. No, protocol client 141. Right. Correct. We were passing down the size of the enum and not the enum type. But yeah, now it's correct. Usize is not allowed. We caught one place where we were trying to serialize a usize. Oh my god. It is so good. Server 87. Yeah. Yeah, this is so bad, man. That's a temporary index that I'm using, and yeah, it's problematic. Okay, so server works. And then we get a horrible crash at some point because we disagree on, because the function that computes the size of a TCP message is too big. In TCP send reply, server 495. So we're trying to serialize. Oh yeah, of course. We're trying to serialize host sync. So host sync is the more complex type of reply. So we changed something. And what I bet you we changed is that some of these things that here are U16s maybe are not U16s on the other end, or something along those lines. Or something along those lines. So let's see, host. These are all U16s, okay, so we don't get weird ideas. Ba-ba-da-bum. Let's take a look at user. These are all U16s for user. Let's look at like chats. Oh, you know what? I know what it is. I think I know what it is. I was using here U16s for the text. That's actually a U24. That's what got out of sync. And I bet you that now it's not gonna crash anymore. Well, no, I wouldn't actually bet. But maybe we did fix it. Yeah, look at it. Oh, no, wait. So, okay. Server is up. Client is up. Client connects. Okay, the connection, something goes wrong. So we borked some of the serialization, deserialization code, but it's not tripping that assertion anymore. So now we are doing things in a maybe more correct way. Are you on Colimac? I am on Colimac, indeed. Okay. So we made some progress. We also regressed something. That's unfortunate. And what's interesting is that, unfortunately, these regressions are like, I should be able to modify the protocol code without always introducing regressions. And I'm making progress towards achieving that goal, meaning making the code more, easy to mutate without always breaking it. The problem is that it's still very manual. Like the end goal is clearly to make all of this stuff be done through reflection. The problem is that I want to do it one step at a time, because if you go bonkers with reflection, then you're sure you don't introduce easily regressions into the protocol, but then you have other kinds of bad side effects. So what are we doing here that is dumb now? Unfortunately, it's hard to say. Oh, you know what? Maybe we can read what this thing has to say. Oh man, there's a lot of DVY spam. Maybe we can kill DVY quick enough so that it doesn't giga spam. Okay, this is the panic that we got. Try TCP message, read slice. We're trying to read a slice. Oh, and we hit end of stream. Also, we are reading message text as a U16. That is also wrong. So I've definitely been bad with regards to things that have to do with messages, because I turned some of those into U16s, even though they should be U24s, and then some things are out of whack now. Okay, so this code should be correct. Now, let's take a look at host sync. Now we write this text as a U24, which is now correct. Do we read it? Also, is the avatar still a U16? Yeah. So do we read it, though, as a U24? I bet you that we don't. Yeah, look at this. So we need to read this as a U24. Let's see how it goes now. Still not good. I'm gonna restart it so that we don't have all the spam. Boom. So we hit end of stream when we don't think we should be hitting end of stream. That's bad. That is bad. Something got a little bit out of whack. What could we have messed up here, honestly? Maybe you know what we can try to do? We can try printing some of these values as we get them as a form of like sanity check to see like is gonna be the host name what we think the host name should be, or is it gonna be something completely out of whack? Because the reality, like chances are there is something slightly out of sync. We don't realize that, and that causes everything to like kind of quote unquote cascade fail. So let's try this. std debug.print. Let's see, like host name. Let's see if the host name that we read is reasonable. Host name, software you can love. So up until there, it hadn't gone out of whack, which is good. I mean, good as a sanity check, although we didn't write a ton of things here. So for now, that's fine. Let's do the same with chat name. So we see chat name general. Allocation size 24 does not match free size 8. This 8 number seems suspicious. Seems gigasus. Allocation. Okay, this tells me the allocation. Do you also tell me where the free was? Yeah, this is wrong. How can this still be in there? God damn it. 107. Man, am I really this dumb? I am. Holy shit. There you go. Okay, so in any case, this does not solve our problem. So name general. So chat name is correct. Let's see if we get right the number of messages. And then I guess we can try to print message ID and author ID. Okay, let's see how that goes. Okay, so message len 9. Message ID 0. Author ID 0. These two values seem reasonable. These values do not seem reasonable. These values are wacky as shit. So these are totally wrong. So I guess we go through one loop correctly, but then things go out of whack after that. And that clearly means that we have wrong code in read slice, and it has to do with the U24. So I know what's going on. I think that with that stupid fucking U24, we are reading 4 bytes and not 3 bytes as I was thinking we would. U24 is a 3 byte integer, but 3 byte is how can I say? It's not a power of 2. So the alignment of that number is 4 bytes of U24. And the problem is that in our case, we kind of want to pack this stuff. So this is problematic. And I guess we can take a look at, like, we can probably test that if we take a U24 and we do as bytes, that returns us 4 bytes, unfortunately. So what is the option? I guess the option would be we don't do U24s as length. That's one way of doing it, I guess. But no, I don't think I want to do this. So I want to do something better. So clearly the problem is dealing with U24s. That's the problem. The question is, how much is it writing though? Okay, so if we try to compile log, it says 4. Size of U24 is 4. And I fear that std mem yeah. And look, that serializes to 4 fucking bytes. You know what's problematic in all of this? What I find problematic is, okay, we serialize it as 4 bytes. Then are we not reading it as 4 bytes? Like, why are things going out of sync? The only reason why I could think that things are going out of sync is if we are reading it wrong, meaning writing writes 4 bytes, but then we only read 3 or something. Yeah, I think we're writing 4 bytes and reading 3. Let's try to print also the message text. I bet you that the first one will also will print, but it will have some weird stuff in it. Frick, where did I leave my logs? Okay, let's see. Message text, hello world. And yeah, look at this. Message text, hello world, exclamation mark, test, 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 pound sign sign. So this is clearly reading stuff that you should be reading. Yeah, all kinds of stuff that you shouldn't be reading. Here's how we can test my hypothesis, I guess. In in read slice, if we're reading a U34, then we try to read a byte and we discard it. Let's see if that makes things go realign. Yeah, it does. Now it works. Now we are connected and we see everything correctly. So that's the problem. The problem is that we write 4 bytes when trying to write a U24, but we only read 3 bytes. That sucks. That really sucks. That really freaking sucks. Then how do we make this happen, man? I don't want that extra bad smelling byte. I want I want to write 3 bytes when I'm writing a U24. God damn it. I guess we do it like this. Let's assume that there are not gonna be any more funky sizes, I guess. So in write int, we say bitcast. The problem is that, maybe I should bitcast, but the problem is that I was using mem as bytes, and mem as bytes is pointer casting. So I suspect that the bitcast will behave in the same silly way. That is my fear. Oh no! Wait. Actually, no. Wait. Never mind. Wait. We do as bytes for enum. And we do int from enum. But for integers, we call read int. So give me a sec. Is it any reader that we worry about? No, because this guy is fine. Reader is fine. It's writer the problem. Okay, no, we do write using as bytes. Mem as bytes is right, I think. Read int is the problem. I don't think so. I would categorize it as the opposite. So as bytes writes 4 bytes for a U24, and then read int reads 3 bytes. I think that read int is right in reading 3 bytes for a U24. The problem is that by doing value as bytes, so doing pointer cast for U24, we get bad behavior. So let me do this. we can say that if I guess we can special case U24, or we can have like a hard-coded list of numbers that we allow to avoid weird problems. But I guess my point is for U24, instead of doing, I guess I can do S bytes and then chop off 1 byte at the end. That's one. I would be curious to do the bitcast thing that you pointed out. But the problem with the bitcast, yeah, something like S bytes, and then we do 0 dot dot div exact bit size of something like this. Okay, so with this we can take out this hack. Will it still work? No. Bit size of still. Wait, are you serious, man? I don't know. I'm gonna put it here. Then okay, then this makes no sense. So bit size of obviously is 24. You divide 24 by 8. That should give you 3. So this should do 0, 3. Type U32 4, U64 8, U16 2, U24 3. Yeah. So this guy does try to make a slice that is too big for U24. But we're slicing. We're slicing. So why are we having trouble? Why are we having trouble? Type info int bits 8. div exact by 8. So this guy is using div exact, delicious, like we are, and it's reading those bytes. Oh, wait, I'm dumb. I'm so sorry. Okay, I know what, this is not working. Up until now, everything that I was changing was client only. So I didn't need to rebuild and restart the server because I only needed to change the client. But now we did change how this stuff gets serialized, and the serialization is done by the server. So we need to reload the server for those changes to get into effect. Fuck, any crashes. So we broke something else. This message has extra bytes. Right. Now the same problem is presenting itself somewhere else. Namely, the way we compute size is in TCP size uses size of. So now we need to do bit size of and then div exact. Pesky U24s. Okay. So we're in business. We're in business. Okay, what is the state of things? The state of things is protocol. The state of things is that the protocol is a little bit better than it was before. Still janky, not perfect, but it now a lot of things previously everything here was a try. Everything was a potential like realloc of a growing array list. Now we got rid of all of that. Now it's TCP size and actually not having space is it's a panic. We can assert that we have space, and not only that, but whenever we try to then take the data slice that we want to send over TCP, we can even assert that there is no unused bytes, so that we are sure that the code that computes that pre-computes how much space we're going to need is perfectly in sync with the serialization code. Obviously, it would be better if basically you kind of would like this kind of the same code like that does these things to do both or something like that. Just like I can offload to metaprogramming the code to compute how something needs to be, then I could do the same for doing these things, because it's so dumb, right? Like, boom, write a U64. Write the mark and then boom, write a U64. Boom, write a byte. Boom, write another byte. Boom, write a slice. So we could totally make this metaprogramming, and we will eventually. So now this stuff works. The server is not hyper allocating stuff at random anymore. We have, I believe, we're dealing well with a lot of circumstances, meaning the life cycle of things like connections, etc., is being done properly for a few things, but not everything. We regress some things. So, for example, we are able a while ago to like join a call and then leave it and then join it again. We're not able to do that anymore because we don't manage the life cycle of these resources correctly. So let's go do that. Let's make it so one can try a voice call multiple times, for example, without having to restart the application every single time. The server, I was about to say, the server does pretty well in that regard, but apparently not. The server pooped itself as well. So So that means that there's some more coding that we need to do also in the server. So let me do a bit of a UDP stream, and I'll be right back. Okay, I'm back. Do 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 do. So yeah, let's fix these problems. So we think that a client should definitely always have a voice, except sometimes it does not. uh, let's fix the server first. Yeah, that seems a good idea. So what is going on there? We're saying there's a call join request. Right. Okay, so that's nice. So that assert is there to say, yeah, this code path is correct under this assumption. Then once this assumption is not gonna be there anymore, you like to get rid of this assert, you need to implement more logic, which I'm not doing right now. That was basically what I was saying when I put this assert there. So what do we do when a client asks to join a call, but to us it's already in a call? So I guess the question number one is, why is that user still in a call if it left the call? Meaning, 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 I think this is state that we're not cleaning up. I guess the first question is, do we actually say anything to the server when we leave a call? I think the answer is no. I think that leaving a call doesn't make the client say anything to the server. So as far as the server was concerned, we were actually still in there, which is not great. So I guess one thing that we could do is have the client communicate that information. I would say that's probably the starting point. Yeah, maybe that's what we should do. Or alternatively, we kind of treat this as a client asking to like switch call. Hmm. Let's do it like this. So first of all, here's what we want to do. I think we want to check if the client is connecting to a voice call that we think the client is already in. We should probably we should cause the client to leave, maybe? No, there's no point, I guess. We might want to do this though, but we're gonna add them back right away. So, like let's say that this is fine. Oh, we're doing put no clobber also. We're doing put no clobber, but actually clobbering is fine. I would say this is all well and good, honestly. The only difference is, I would say that the only difference is, before we set this, well, we need to, I think we need to do it like this. If the client was already in a voice channel, then we need to go get it out of there, basically, to keep things consistent. We grab from the voice index the old voice ID, and we remove. Now remove. Well, actually, I don't want get or put. I want remove. I guess it's a swap remove in this case. Wait, no. I get the voice channel and then I do swap remove on that. Oh, wait, what? No, okay. Like this. There you go. Okay, so if the client was somewhere else, we remove it. Okay, so this stuff seems fine. With this, I think that the server should not crash anymore as we try to join things. I think we need a second voice channel now to test things a little bit more. Client crashed, but not the server. The server is fine. The client had trouble. Okay, so now I guess the next roadblock is in the client. Thread mutex. Capture buffer was full flashing, but then we reach unreachable code in the mutex code. I guess that's a deadlock condition, basically. We're probably, yeah, what's going on is that we're trying to grab probably a lock to that thing from a thread that already owns the lock or some weird thing like that. So clearly not handling the lifecycle of things correctly. Okay, the only thing that I don't like about this code is that I'm not sure what the procedure should be if the client wants to join a channel that we already think they're in. If we already think that they're in a channel, should we like remove them and then re-add them? Like this part could be skipped. Well, the problem is I don't want this to be fully a no-op because if the client is asking, it means that it somehow lost context. So we think that they're still inside, but the client doesn't. And so it makes sense for us to give the client, for example, other replies. I think. Yeah, the thing is, I'm not 100% sure. So you know what? Let's leave that A to do, maybe. So, okay, let's go into the client. So this stuff is basically client media. So this code is going to be split between client media, client app, and client network. But I think that the stuff that gives us trouble is gonna be media. Oh, actually, you know what? I think all three have trouble. Um, let's start from app, maybe. So we join a call. Well, we ask to join a call. When we ask to join a call, that puts us in a situation where we care about the existence of that call. So we mutate our state. So now we are in the process of joining a call, and there's also a state variable in there. Status, yeah, that says that we are in state intent. We start at intent, and then we can move to connecting, connected, disconnected, and finally quit. This is like atomic enums in my code base. This is a thing that I've implemented this. It's like a tiny state machine. It's not a fully well specified state machine. It has a starting state, a bunch of intermediate states that you can move freely between. So in a full-fledged state machine, you would want maybe to put restrictions in some of those transitions. I don't have that as part of the atomic enum code. And then there's a final state. And the final state is final. Once you get there could be more than one final state. But once you get to a final state, then you can't change anything anymore. This is and this happens through atomic mutations. So atomic read, atomic set. And this helps with coordinating across things in a more, let's say, lightweight way than mutex is, I think. So host voice. So we move ourselves in the state of, yes, we have the intent. We're intending to join a call. We get a handle to the to our current connection to the server, and we ask the network to process this new command where we basically just say that we want to join a voice call. Yeah. Then this sends a network request, then we get a reply. So this part is easy. We get a reply. We need to worry a little bit about what is the UI going to do. Like, okay, basically what we care about is who is going to free this guy. We need to make sure that this guy gets freed in the correct way, and that's where the atomic enum helps, because there's going to be like a bunch of concurrent things going on. So let's go into the network. Call join. This is just a callback that makes us send a command, but then we get a reply. The reply that we get from the server, let's see, ingest commands. Where do we get replies, and where do we put them? Oh, you know what? I think we give them directly to app whenever we get a message from the network. Command locked, state locked. Do we not have that? Run network init while true. Hosting channel update. There we go. Media connection details is the reply to call join. So we receive from the network media connection details reply, which prints this funny to do. Okay, let's get rid of it. So we deserialize a media connection details protocol, which tells us the voice channel that we're trying to connect to. We know that already. It's just a way to make sure that we understand what they are replying to. Like, they are replying to us trying to join voice, a specific voice channel. So in case that you press a bunch of buttons and we don't mix them up. That's why it's echoed back. Then TCP client and nonce. So we get the details to connect. And here we do things. So we lock the state. Then we look at the active call. We confirm that the call that we're trying to join is the voice channel that we're trying to join is the one that the server gave us details about. Otherwise, like if we don't have an active call, then it means that we're not trying to connect anymore. So we ignore that reply. If we are trying to join a call, but it's not the same voice channel, then we ignore it because also that's a channel that we don't care about. This is the result of like the user pressing a bunch of buttons, for example, potentially. Then if all of this works, then we make sure that we are also still in the state of being in, right. Here we say, okay, then to move forward, we also need to still be in the intent state and we want to transition to connecting. If this succeeds, going from intent to connecting, then great. Otherwise, we ignore the message anyway because we are already connected. So this is like the server could, in theory, by mistake or whatever happens, a malicious server could send us like the same message twice. So we ignore it if we are already connected. Okay, so this moves forward the state of the active call. If we are here, then we activate audio streams. And we ask the network layer to open a stream. Great. Let's look at media activate. Media activate is literally just going to open audio streams, right? So like thread init, thread the init, stream, open streams. And then we have the deactivate audio stream. So we need at some point to call the activate audio stream when we don't want to like listen to the microphone anymore, that kind of stuff. Which I think we're not calling anywhere because I haven't handled this whole this whole lifecycle management was previously implemented in a very different way. So now everything is has been destroyed and we need to rebuild it. So network starts opening a stream there. So this all seems great. Now, what we are missing is any of these things could error out. And when they error out is when we need to leave the call because we're erroring out. Command, for example, here, once we're in here, we should defer that we basically need to kind of close the call, I guess, if we're erroring out while trying to do this. Like this try could error out. I guess an error here should actually be like a application-wide panic, maybe, potentially, I don't know. But let's I don't know exactly this try, how far up it goes and what happens to it. But let's guarantee the property that if we're like exiting here with an error, then it means that we're also cleaning up this active call and we're killing it. So right now we have some connection active call killing code in the leave button. When you press the leave button, that kills the current active call. So we could maybe look into that to see, to be reminded exactly what it entails to kill a call properly. But we could actually maybe, we could have like a fucking the init function, although in here it would be more complicated. Let me think about it. If this errors out, we want to deactivate this. Actually, no, we don't, because deactivate is unnecessary in that case. Actually, would it be problematic to do that? Oh yeah, it would totally be super problematic. Yeah. Mm-hmm. So in this case, this cannot fail. This cannot fail. So the only thing that we have to worry about is this guy failing. Do we have AC? No, do we have like AC.dinit? We don't have the init. We should give it the init, I think. Let me think about it for a moment. So failure in this function actually, okay, because the thing is, normally this lifecycle management needs to be more complicated, but here we are setting it up. So the code can be simpler, just more, I guess, nuanced. So if we are at this point, also we are locking the state, so that's also good. I'll assume that the UI does not hold a pointer to this thing, although it could. Maybe it does. Let's assume it does not for now. So let's just free it. Okay, we'll see what happens afterwards. Okay, so we try to activate audio. Hopefully everything goes well. Network starts listening. I guess the leave button basically is the one button that we need to worry about for now. Now, where is the leave button though? Call join, call leave. There we go. Call leave. Let's see. Call leave assumes that the state is locked, grabs the active call. If there is no active call, we're happy. If there is one, puts it to null. By the way, are we fucking making it? No, we are calling destroy on it. Okay. So what are we doing here? Old status is AC status update swap quit. Okay, so what we're saying is we move to quit and we look at the old status. If the old status was intent, it means that we never. The assumption is that if the state was still intent, nobody holds a handle to that connection, to the active call. If the state is not intent, it means that somebody else out there holds a reference to it. And the question is, do we actually do that? Let's see. Here we do media activate, but we don't give AC to this guy. Well, we use all of state. Does it care about active call at all? No, doesn't even mention it. Do we care about here? We don't even care about here. Oh, that's so funny. I think my original expectation was, or like, you know what? The older implementation had some other components hold a reference to the active call, and now they don't. That's funny. Now they don't. Now they just don't. So who else might try to kill this call? Yeah, previously we had like threads and stuff. I think the only thing that we need to do here, like we can change this. We can just do it unconditionally, I think. For now, we can just do it unconditionally. And then we need to do try media dot deactivate what? Deactivate audio stream. Maybe we can just call it deactivate if the other thing is called activate. So we media deactivate, and then we need to. Oh, okay. So here's the thing. Wait. Actually, no. This is the thing. So we do destroy this thing unconditionally, but if the old status is intent, I guess different than intent. If we were still at intent, well, how can we put this? Having moved past intent means that we have activated the audio stream. So try. Is it even a try? Yeah, I think it is a try. Is it? No, it's not. Oh, thank God. So now we need to also ask the network to stop pulling from that thing. How do we do that? I think it also requires us to release locks and stuff. Release locks and shit. Something like this. So let's ask the network. Network. Command. Call leave. Yeah, I think it can even be like this. We don't even need to specify anything, I think. So we leave the network. No field name call leave. Yeah, I know. We're gonna add it now. Call join. Call leave. I'm gonna put it above. So yeah, this should basically how do we say that we want to leave a call? What does it even mean? I guess what we can do is close the socket. That ought to do it. Like we just straight up close the socket and call it a day. Oh, instead of call leave, I think we should call it like close stream. Now that I think about it. Yeah. Close stream. Yeah, and this should be like stream open actually. Yeah, stream open, stream close. I think I understand now what my plans were originally for active call. Basically, now what I'm trying to do here is I don't have a handle to that UDP connection. I don't have a handle to the resources that were associated with the previous call. And that is, some of it is fine because these are kind of global singletons. I can make them global singletons, but at the same time, I expected some of this stuff to be put inside the active call struct. Yeah. And I expected also potentially some cleanup code to still be running while we're joining already a new call. So that's why it was like a heap allocated thing. But now that I think about it, it's more synchronous than that. Like in practice, we can't really join a new call until the audio teardown is complete or the network one is complete. I mean, we could, I guess, make it work in a more asynchronous fashion, but I'm not sure what is there to gain. Yeah. Also, I think we need to stop the network first and then call. Yeah, we can't media deactivate in there ourselves. I think media deactivate is best if it's the network calling it. Although, stop. Thread the init. And my function expected one argument. Oh. I don't think it even goes here. It goes somewhere else still. So how do we cause the UDP connection to die? We need to keep somewhere a handle to it. To have UDP send, we have open stream, we have a pool in here. We put UDP inside the server. What? I guess that's a choice. Yeah, I guess that's a choice. I guess that's a choice. I guess that's a choice indeed. So I guess I want to pass the host connection to that command. That way we can close it and clean up the bookkeeping, I guess. Now these errors are all catch unreachable. Now we need to make it different. Oh my god. Okay. Okay, give me a sec. I'll be right back and then I'm gonna work on this. Okay, let's get into it. So that command needs to have more stuff to it. Needs to have a host connection. So HC. Oh no, actually it's stream close. Stream close.hc dot close stream. Hopefully we don't need to try this. So that's how it has to be implemented. Let's go implement it under OpenStream, or maybe even above of it. We have a UDP pool going on in here. Interesting. I guess we can leave it there. We don't need to de-init it. Okay, so how do we close this stream? Actually, this can be like this. So closing a stream, huh? hc.udp dot close dot sock dot close. Don't tell me this is async. Oh, we don't even know. No definition found. Oh, right. Let's log what's going on because this is weird. What's your problem, dude? Why don't you want to give me help? Oh, there we go. Yeah, expected 5 arguments. Freak. Actually, wait. We can't even trust ZLS on this. Let's take a look at UDP. UDP is, well, let's look at the send to one. Okay. It does have close. So it does close, and closing is an async thing. So the closing a socket, it's a long process. And to be fair, there might be outstanding rights and stuff. So yeah, this is an async process. Okay. Let's take a look at this thing. Let's take a look at close. This is what close looks like. Loop, is it a global? Please tell me it's a global. Please tell me we have a global loop. No, it's inside the host connection. God damn it. Okay, fine. We need a completion. So we're gonna need a like something like hc.close.udp.close c. We probably don't have that. User data. Yeah, right. What do we pass in there? I don't think we care about passing anything. Okay, so this should close the socket. And so we should also do here media dot well, here's the problem though. We have closed the socket, but then there might be pending reads and writes and God knows what the fuck. And we don't have a janitor for this guy. Let's do it like this. Let's put an answer that we can trip and then fix eventually. No, at the end of the day, we do want actually the host connection. Okay, so we need to add stuff to UDP, that's for sure. There's an async C even. Oh my fucking god. There's so much stuff, man. There's an async C even. Yeah, I'm actually not closing this correctly. Like there needs to be a lot more orchestration. Basically, I need to before I can really delete this, I need to close the socket, move it into a closing state, probably even shut it down. That should unblock a few things, but then there's also this async thing waiting. So we also need to make this. This is waiting for new stuff from the microphone. Yeah. So shutting this stuff down correctly is a little bit more nuanced than what I did until now, but let's see how far we can go with this. Is it handle? I don't remember. Handle, connection. Expected type, right, and then the return thing is not okay. Expected type command struct found client only connection. Oh, dot handle. Oh, let's see what happened now. Try to update a terminal status. Interesting. Call leave. Sets the call to quit. There's something else that sets the call to quit. Try to update a terminal status. Call 328. Or up 328. Was it already in a terminal status? So like, what is the problem? Let me just restart the server. Try to update a terminal status. Maybe we can make this more useful and like it could tell us more. It could tell us what the old status was. Although if it's a terminal status, it means that the previous status was already quit. Like who put that thing to quit? Place walk back compare. Update. I'm a little bit confused. Update safety. Update swap. If built-in mode debug, we look at the current state. And if the current state is past progress, then we complain. So this has to do with the current state. I guess give me the current, let's print the current state. Oh, I'm dumb. Oh my god. He gives me an atomic key and I'm, wait, what? Like that shitty thing didn't print anything? Panic invalid enum value. Panic invalid enum value. There's somebody else that deletes that thing. What? Okay, so here's what happened. It was trying to print, so it prints the all the type thing, and then it's trying to print the actual value. Like here is where the actual current value should be, but then it panics because it's an invalid enum value. Okay, that is not great. That is definitely not great. Where else do we try to free that thing? Call join Erdefer destroys it. Which is not even a thing anymore because we don't error out past this point anymore. This doesn't error out, this doesn't error out, nothing errors out, so this can even be removed. Then call leave. Oh, am I dumb? I was destroying it here right away. I was destroying it right away. That's why we are having all this much trouble. The problem is okay, the question is, do we want to do this before we destroy it? Yeah, we definitely do want to do that before we destroy it. I guess we can defer destroy it. Maybe. We hit unreachable in KQ. Okay, so yeah, our libxcv code is way too simplistic because there's a few things that we would need to disarm that we don't know how to disarm, and well, that we just do not disarm at the moment. So in a sense, like if I were to take this out, yeah, it still works. The problem is that we cause, yeah, the lifecycle management is not correct. There's bad stuff that happens, but we don't crash anymore. Okay, so basically, correctly shutting down the network is the next thing that I need to do. So I think I'm gonna stop here. I'm gonna do that work maybe in Discord. So thank you all for hanging out. I hope everybody had a nice, I don't know, experience. And I think I'll see you next time. So see you all. Bye bye.